It has been said that pollution, such as air and water pollution, is an unavoidable byproduct of industrialization, especially in developing countries. In spite of its significant economic growth in the last decade, China is now facing a severe water pollution problem. Is it really unavoidable? Can water pollution be controlled and fixed? In this program, Professor He Fa Chung of the Guangzhou Institute of Geochemistry gives a wide-ranging overview of water pollution in China and some suggestions on the long-term solution to water shortages.
Here is an outline for my talk. It's divided into 6 parts. First, I'm going to give a quick overview on water resources distribution in China. Then I'm going to very quickly cover the water pollution situations in China. I'm going to focus on the causes of water pollution in China and also the recent national effort on control water body pollutions. Towards the end, I'm going to make some recommendations on how to improve the water resources management in China and also present our perspective on how to solve the water shortages in China in the long term. China is a country with the largest population, basically. So right now, we have around 1.3 billion people. It's ranked 6th in total water resources in the world. So if you divide the number of water resources by the population, you get a fairly low number of less than 2,200 cubic meters per capita. So this number is only a quarter of the global average. So in terms of the per capita water resource availability, China is quite deficient in water resources. In fact, it's listed in one of the 13 water deficient countries in the world. Right now, more than 400 cities, also a total of 600 medium to large scale cities in China, suffers water shortages. And this figure shows the major water basins in China. We have in the north side, we have the Songhua River Basin, the Liao River Basin, and this part is known as the North China Plain. It has the Han River Basin, Yellow River Basin, and the Huai River Basin. On the southeast, we have the Lake Tai Basin, Lake Chao Basin, and the Southeast River Basin system. Then this is the Yangtze River Basin and the Pearl River Basin here. We also have the Lake Dian Basin, Southeast River systems, and also the inland river systems. And the water resources distribution in all these basins are quite different. And here, this shows an overview on water supply and the demand in China over the last 2 decades. So basically, from 1997 to 2006, you can see the total water supply has remained relatively stable. And more than 80% of the water supply in China come from surface water. Then about 15% come from groundwater, while the rainwater utilizations and also seawater utilization contribute very tiny fractions. Here, the bottom figure shows the water demand from 1980 to 2006, and also the projected water demand in 2030. This is population growth. So the total water demand matches the population growth very well. And overall, the agricultural water demand over almost 2 decades hasn't changed much. While there has been significant increase in industrial water demand and also domestic water demand, basically household uses. Basically, that's due to the rapid industrialization and urbanization in China. It's also projected by 2030, the per capita freshwater availability is only going to be around 1,760 cubic meters per capita. So this is quite close to the internationally recognized water stretch level of 1,700 cubic meters per capita. So it's projected by 2030 as a whole country, China will suffer water stress. And here, this figure shows the distribution of water resources in China. Basically, China has a marked continental monsoonal climate. So all the coastal regions are quite abundant in water resources, while the inland areas and also in the north part doesn't have enough water resources. And here, this shows the population density. Basically, most of the China's population are located in the coastal regions. And this shows the industrial activities. So basically, all the industry are also located in this part of China. And the per capita GDP, also the coastal regions have distinctly high gross domestic products. And by matching the gross domestic product, industrial output, and also the water resources distribution, there are some distinctions we can see on the distribution maps. First of all, in the North China Plain, in this region, it has only about 8% of the total country's water resources, while it has 1/3 of the country's population, gross domestic product, and also industrial output. In contrast, in the southwest region, it has around 20% of the country's water resources, while it's only produced less than 1% of the country's GDP and the industrial output. So there is a significant mismatch between the water resources and the water demand in China. And also in this region, in this southern part of China, including the Pearl River Delta region, it's well endowed with water resources. However, due to the rapid industrialization process and urban growth, there has been significant water pollution. As a result, this region also suffers the shortage of good quality water. And there has also been significant intra-annual and inter-annual variabilities in China's water resources. Here, particularly in northern China, here they show the data from the high river basin. And basically you can see the most of the precipitation occurs during the summertime from May to August, while the rest of the year has very little precipitation. So this means in the summertime, you are going to have a lot of too much water that cannot be fully utilized or captured. While in the rest of the year, there is pretty much no precipitation and it gets very dry. While in summer, you have flooding events. Also, there is a significant interannual variabilities. This shows the annual precipitation in 2002, 2003 in different provinces in China, Beijing, Tianjin, Hebei, and also other provinces. Here, basically by looking at the data from 2002 and 2003, we can see that there is up to around 20 to 25% variations in the annual precipitation. In fact, history record shows that the wettest year in northern China can have up to 8 times the precipitation of the drier years. So basically, the significant temporal variation in precipitation or in water resources supply makes it very difficult to fully utilize the limited water resources in China. We all know that water is a vital element in our daily life and is critical to the sustainability of society. So how China must make the limited water supply to meet the demand for agricultural irrigations, industrial production, and also for domestic consumption and protect the natural environment and the ecosystems. So water is to ensure the water supply is a key sustainability question for China. And next, I'm going to cover some images on water pollution in China because I think all of you have some ideas on how bad the situation is. But I'm going to show some extreme examples. So here is the pollution in Songhua River in 2005, basically due to an explosion of a petrochemical plant. Basically, a lot of benzene and natural benzenes were released into this river and turned the river totally into black. And here, this is something you can probably see in a lot of places in China, especially in Pearl River, due to the release of dyes and other chemicals from the very small manufacturing facilities. And here is the wastewater discharge into the Yellow River. They almost become small rivers. This is a wastewater discharge point. And here is the algae bloom in Lake Tai. And here is the drinking water during the algae bloom season in Wuxi City. Although the water looks okay, but people cannot drink it. It smells terrible, and there are a lot of algotoxins in this water. And here are more pictures taken by Guang Lu, who is the recipient of 2009 Eugene Smith grant in humanistic photography. He took a lot of pictures on water pollution in China. Basically, a pond in one of the electronic waste recycling villages in Pearl River Delta. And here, these are 2 geysers of wastewater discharge into the Yangtze River. And this one shows the pipe buried below the water surface. So basically, large volume of wastewater was discharged into these rivers. Based on the color, you can tell they are not treated at all. And here is the titanium oxide laden wastewater discharged into a river and turned the water totally into white colors. I think these are quite shocking images, and this basically illustrates the seriousness and the scales of water pollution in China. Basically, one of the biggest impacts of water pollution is that such heavily polluted water is not usable. You cannot use them for anything, not for agricultural irrigation. So water pollution essentially reduces the good quality water and further reduce the amount of water, makes the water shortage worse. Next, on the cause of water pollution, I attribute to 2 factors. The first one is basically growing pains, I call it. The second is poor management. I'm going to discuss them in more details. Basically, this shows the gross domestic product growth in China from 1960 to 2010. And here we can see basically in the late 1970s, basically 1979, China began the opening up policy and the economic reform. You can see that after that, China's economy took off and basically follows exponential growth. Well, this shows the air pollution in Linfen city in Shanxi, basically. It's listed as one of the world's most polluted cities by Times Magazine in 2007. You can see that it looks horrible. Well, here I show some pictures from the United Kingdom and the United States during their industrial revolution process. It shows a small English town in the late 1970s. I would say that these two places looks pretty similar. That's during the peak of the industrial revolution in United Kingdom. And here in the United States in 1952. And this is an urban river in Cleveland, Ohio. Actually, this river was heavily polluted, and there's a very thick layer of oil floating on top of the river surface, and it caught fire several times. And this time it took about 2 to 3 weeks for them to put out the fire. And after that, the Congress in the USA enacted the Clean Water Act. So before 1954, the water pollution in the United States also very heavy and heavily contaminated. So I wouldn't say that the water pollution in China is justified, but I would argue based on the history record that with rapid industrialization and urban growth, and pollution is something that's almost unavoidable. And basically, there is so much waste produced, and the social system and the legal system is not adjusted fast enough to keep track or to control the water pollutions. And another big contributor for water pollution is basically the physical shortage in water, and therefore there is excessive water obstructions from all the rivers in China. Here I show the water obstruction from all the major river basins in China. And Songhua and Liao River are in the northeast part of China. The Hai River, Yellow River, and the Huai River are in the North China Plain. Yangtze River and these rivers are in the south part, while this is northwest part. Here we can see that basically in North China, the water resources is quite limited, so there is excessive water obstructions. And the water obstruction from these basins reach around 50%. In particular, for the Hai River Basin, we can say that the water obstruction exceeds 100%. They reach up around 120%. So basically, the actual water has to be transferred from the Yellow River Basin to make up the water demand in the Hai River Basins. Now, in the south part of China, because there is abundant surface water, so there is not too much obstruction from the river systems. And for North China, there is significant intra-annual variability in water resources. Basically, in the summertime, you have a lot of water, so while in the dry season, you don't have too much water. So as a result, the water flow is quite low, except during flooding season. So during flooding season, you have too much water, while the rest of the year you have no water, and the water could just become a big sewer for the wastewater. And here this shows the pollutant discharge from the industrial and the municipal sectors. These bars represent the total capacity of wastewater treatment. You can see from 1995 to 2008, there is about 6 to 8 times increase in total wastewater treatment capacities. Over the same period, the fraction of wastewater treated only increased from around 30% to around near 70%. So there is, with 8 times increase in wastewater treatment capacity, you only increase the fraction of wastewater treated by 2 times. So basically, there is a significant increase in the amount of wastewater discharge over this period. And here this shows the chemical oxygen demand, or COD, discharge from 2000 to 2008. The bottom represents the industrial sources, while the top represents the municipal sources. Here we can see that the COD discharged by industrial wastewater has been actually declining a little bit, while there is the contribution from municipal sector has been increasing. As a result, the total amount of COD discharge has been stable. And similar thing is observed for the ammonia and nitrogen. So overall, there is a decrease in ammonia and nitrogen discharge from the industrial wastewater, while the municipal wastewater catch up, and they become the largest contributor for the ammonia and nitrogen. In terms of volume, municipal wastewater is also has a greater contribution to the water pollution than industrial wastewater. So right now, because of the rapid urbanization, urban growth in China, actually municipal wastewater become a bigger contributors for water pollution instead of the industrial wastewater. And here it shows the major pollution industries in China. Basically, these are known as pharmaceuticals and also metal manufacturing, textiles, and chemical industry, and also light industry that makes consumer products. So together they contribute to around 60% of the chemical oxygen demand and also 6% of ammonia nitrogen. So in these different river basin systems. The only exception is Lake Dian here. Here the ammonia nitrogen primarily come from the agricultural runoff. So basically these are the major industrial polluters in China. And here I want to show you a table on the water quality standard in China. Somebody may think that China do not have a good water quality system, so we have such a widespread pollution. So this is not true. China has quite comprehensive water quality standard compared to the United States or the WHO standard. So basically, a lot of the common pollutants are included in this table. Basically, we have COD, BOD, ammonia, nitrogen, phosphorus, heavy metal like copper, zinc, and we also have arsenic, mercury, cadmium, chrome. So the list is quite long and comprehensive. Based on the classification system, the water body in China are classified into 5 categories. So these are grade 1 to grade 3. These are good water that can be used for drinking water supplies. While grade 4 and grade 5 are bad water, but they can still be used for general industrial use and for agriculture, recreational, and also landscaping irrigations. Well, there are also another category that's not listed into the system. It's known as inferior to grade 5. Basically, the water is so heavily polluted that it has no practical use. So basically, anything that fell below grade 5 is known as inferior to grade 5. And they basically essentially sewage, and you cannot use it for anything. And here, this figure is going to show the water quality distribution in all these river basin systems in China from 2000 to 2008. So because we don't have all the data, but just to show you the trend. The red represents the bad water, and the green represents the good water. The yellow means the grade 4 to 5. From 2000 to 2008, there hasn't been too much change in the water qualities. There is a slight improvement in some of the river basins. Basically, the water quality are increasing slightly in some of the basins, but most of the basins still remain the same. And also, the pollution situation are now quite different, very significantly from different basins to different basins. So based on the water qualities in different basins, we got some general conclusion. Basically, about 6% of river sections, 44% of lake areas, 80% of reservoirs, and 26% of the groundwaters have good water that can be used for drinking water supplies. While around 20% of the river sections, 23% of lake areas, and 4% of reservoirs are so heavily polluted that the water quality fell below grade 5. Basically, the water is lost for any use. It's not good for any use. So this is a significant amount of water if you consider 20 to 23% in rivers and in lakes. In reservoirs, the water quality are generally good because these are purposely built as water supplies. They do not allow the water to go so bad, but still 4% of the reservoirs have very polluted water. And in terms of the drinking water safety in China, basically organic pollutants, heavy metals, ammonia, nitrogen, and also disinfection byproduct, bacterial, virus, micropollutants can all be found in tap water in China. So I don't want to comment on how safe the drinking water is in China, but I think as you probably all know that bottled water is very popular in China. And here I only have the data in 2003. Basically in 2003, around 1,000 tons of bottled water was consumed, and the market value was 30 billion yuan renminbi. Also, the market growth was around 16% in 2003. So there is a huge market for bottled water because the public do not trust the quality of the tap water you got from the municipal supply. And the second biggest contributor for water pollution is poor management, I would call this. Here is a cartoon illustrating this process. Because multiple government agencies and institutions are involved in water management. So when there's a profit, everybody wants to reach for that and grab the profit. However, when there's responsibility, nobody wants to take the responsibility, if you look at the fingers here. So that's described the water quality management in China very well. And we all know that water pollution is basically a transboundary and accumulative nature. It doesn't take one farmer to pollute the entire river system, basically. So the farmers may produce some of the agricultural chemicals, release some of the pesticide and their fertilizer into the rivers. Then we have villages discharge their domestic wastewaters. Then we have cities discharge their sewage. We have industries discharge their industrial wastewater. Some of the pollutants get degraded along the river section, but most of them accumulate, and so suddenly the water quality becomes so bad. The dissolved oxygen went to below 0, then the water went very totally bad. So, but this is a transboundary issue, and it's quite accumulative. And because there are many functional zones and sources and treatment systems and discharge standards involved, so this makes water pollution or river pollution very difficult to manage. While the Chinese institutional system on water quality or water resources management makes it further difficult to effectively manage water resources. Basically, under the State Council, there are 8 ministry-level government agencies involved. These are known as the Ministry of Water Resources, Ministry of Environmental Protection, and also Ministry of Urban and Rural Constructions, and other ministries. So they are in charge of different aspects of water resources management. The Ministry of Water Resources is primarily in charge of water resources, while the Ministry of Environmental Protection is in charge of water pollution. Well, Chinese system is known as a dual leadership system. So under the Ministry of Water Resources, we have all the provincial level and also county level and local level. They have their local branches. Well, we also have this local government. So in the end, at the bottom level, so basically this water resources station is under the dual leadership of the upper level water resources bureau and also the local government. So it follows the order of both these agencies, while it's financially and politically dependent on the local government. So it's found and the personal appointment come from the local government. So while the local government is more interested in developing the economy and GDP growth, so most of the time they don't care about the pollutions. So this makes it very difficult to effectively manage the water. Also, there are a total of 8 ministry-level government agencies involved in water management. So now, not a single agency has the full responsibility for water resource management and also for pollution controls. So this is known as the Night Dragon Control One River in China. In terms of the legal system, I would say that China has a very well-established legal system in terms of water resources management and water quality management. There are national laws such as the Environmental Protection Law, the Law on Prevention and Control Water Pollution, and also the water laws. On the State Council level, we have all the different administrative statutes, and also we have on the minister level, we have these ministerial regulations. Also on the provincial and local government, they also make their own laws and regulations. So overall, the national laws and the rules set the principles. They are quite general, but the local laws and regulations are formulated based on the local needs and local situations. But the real problem is that besides the presence of these laws and regulations, they are often not implemented or enforced. Because there are different ministries involved, and so there is a lack of coherence in laws and regulations, basically set out, at least by the different ministries. Also, the enforcement of the different laws in different regions can be quite different. And also on the different levels of the government agencies, they have different interests. So the local government is more interested in developing the local economy, while the central government is more interested in protecting the overall the environment and the water qualities. Also, in terms of the authorities on any single institution, such as the Ministry of Water Resources or the Ministry of Environmental Protection, they do not have the sufficient authorities and the resources to carry out the law enforcement activities. And this cartoon basically illustrates the situation in China. The government official promotion system is GDP-oriented. So basically, if you can develop the economy very well, you have high GDP growth, then you get promoted very quickly. So this translates to the government decisions. Basically, the government official want to try to avoid those that can contribute to GDP growth, such as those basically major industries. They are the major polluters, but they also contribute to the high employment, and also the GDP growth of apparent economic growth. This is the root of the poor enforcement. And next, I'm going to talk about the national efforts on control water body pollutions. Basically, realizing the damage caused by water pollution and also the water shortages in China, the government began to take national campaigns on water pollution in recent years. It basically includes 2 sides. The first side is engineer, and second aspect is policy. And in terms of the engineer effort, it's very simple. Right now, around 35% of wastewater in China is not treated, so basically they try to build more wastewater treatment facilities. And here, the overall objective of this national campaign is basically to establish technical systems for water pollution control and treatment, as well as water environment management at basin scales through innovation of concept, technology, and management. And also to break through key technologies with emphasis on basic pollution source controls, and also strengthening the monitoring capacities, and also improving the water environment quality and ensure safe drinking water. And the total budget set aside was around 36 billion yuan renminbi, and with the central government contribute to around 40% of this. So far, 33 projects have been listed. And here you can see this. The leading authorities on this water pollution control again shows the problem in institutional systems. We have two ministries in charge of the same task. We have the Ministry of Environment Protection and the Ministry of Housing and Rural Urban Development. Instead of one government agency, they have two government agencies in charge of one task. Because these are all ministry level agencies, so they have the same authorities. So I don't know if there's a conflict of interest between these two agencies, who is going to solve their dispute. And the target watershed are listed. Basically, right now there are 4 river basins, 3 lake basins, and 1 reservoirs included in these national campaigns. So basically, these are all the heavily polluted river basins. Basically, the Fenghua River basins, and we have the Liao River basin, Hai River basin, Huai River basin, Lake Chao, and Lake Dian basin. These are all, you can see based on the appearance of this green color, you can see basically all the region with bad water are included. The only exception is in the Three Gorge reservoirs. This river system, basically the Yangtze River has relatively good water qualities, but Three Gorge reservoir was included because of the strategic importance of this reservoir, in particular in China, for the south to north water transfers. So they want to preserve the water quality in this basin. Also, another big problem that with the completion of the Three Gorge Dam, the water quality is actually quickly deteriorating in this Three Gorge reservoir. So that's why they included this. In terms of the pollution source for the surface water, right now about 9% of the industrial effluent is untreated, and 6% of the municipal wastewater is untreated, and agricultural runoff is not treated. So that's why they include this. Basically, to treat the industrial wastewater, agricultural runoff, and also municipal wastewater, and then to improve the water quality in the polluted water bodies, also to ensure safe drinking water and aspect water quality monitor and supervisions. Field demonstrations are key components in these national campaigns because they want to see results. So these include lake eutrophication controls, and also river pollution control and management, urban river pollution controls, and also safe drinking water and watershed management. In terms of policy effort, I would say that it's relatively weak right now. Basically, they only try to include the financing and investment of water pollution, and also to have different taxations on pollutant discharge, and also have pollutant discharge permit and tradings and compensation, public participation, and information closure. So it's relatively weak compared to the engineering effort. Based on the causes of water pollution in China, I would say that the root for the water pollution in China is actually due to the poor management. We want to make some recommendations on how to improve the water resources management or water quality management. First of all is basically the law and the regulation enforcement. Right now in China, there are 17 national laws, administrative laws, and regulations on water pollution controls. And there are also 21 national quality standards for watershed discharge, and 6 national water quality monitoring standards. So there's very well established laws and quality standards in terms of the wastewater discharge. So we still get this bad water because they are not enforced. Nobody really treats their water to meet the quality standards. Also, in terms of the wastewater treatment technology, I believe that at least in terms of the basic wastewater treatment technology, they are available in China, and we have the expertise, we have the experience. So and also the China's economy can afford these technologies. And just as an example of the Pearl River pollution controls, once the government sets their money, they put their money, they allocate the money, then they can control the water pollutions. But most of the time, they just don't want to take actions. So the implementation and enforcement is really a big problem in terms of the water pollution controls. Also, the government needs to acknowledge there are regional differences and the regional benefits, basically, as shown with the previous examples. You cannot ask the farmer to treat their wastewater and also their agricultural runoffs because they make very little money. So there is need to develop a compensation mechanisms for different parties that get involved in water pollution to take actions to reduce their pollutant discharge. And also, because the transponder issue, the water pollutions, there is need to basically develop a unified management systems. And also there is need to have environmental cost accounting systems because right now the wastewater discharge permits in China do not reflect the environmental cost, and there is a need to basically develop a market-based water price to include not only the resource cost and delivery cost, but also the wastewater treatment cost. And also, in 2004, China tried to develop an economic index called green GDP, basically used to factor in the environmental consequences of economic growth. It was estimated that the financial loss caused by pollution in that year was around 500 billion yuan renminbi at that time, or 3% of the national economy. It's also estimated that the cost of environmental degradation and resource depletion for the last decade ranged from 8 to 12% of the GDP growth. Well, you all know that China's economic growth rate over the past decade has been on average around, I think, around 10% over the last decade. So essentially, it means the apparent economic growth in China over the last decade basically based on the environmental degradation and the resource depletion. There is no real economic growth based on this estimation. Because this result doesn't look good to any government officials, so they totally throw this green GDP concept away. Because it doesn't look good for any officials, so they no longer use this system. In terms of institutional reforms, there is a need to basically develop a government evaluation system that considers both pollution management and also economic growth instead of only look at the GDP for the official promotion. Also, right now, the Ministry of Environmental Protection is very weak. It has very limited funding, and it's politically and financially dependent on local government. So there is a need to basically establish political and financially independent government agencies that supervise water pollution controls. Essentially, China needs to basically have a significant reform to change the water resource management to have integrated, efficient, and effective institutional systems. And finally, I'm going to talk about some of our perspective, our thoughts on how to solve the long-term water shortages in China. Basically, we believe that economic growth can be a big factor. Although China's water shortage arises from economic growth over the last 3 decades, we believe that further economic growth or economic transformations from extensive to intensive growth can actually reduce the consumption or demand of water resources and also reduce the water pollution. So basically, this can be seen from this. Right now, China has a very large manufacturing economy. It's energy and resource intensive and cause a lot of pollutions. While some of the cities big cities are trying to transition towards a service-based economy, basically, by developing service sectors, and then it's going to reduce the footprint on the environment. Also, ultimately, China tries to build a knowledge-based economy, and also here in Hong Kong, I know the government has the same goal, basically. If we have a fully knowledge-based economy, then it means we are going to use very little natural resources. We are going to have release very small amount of pollutant into the environment. So basically, economic transformations from manufacturing toward a knowledge-based economy is going to reduce the water demand and also reduce the amount of pollutant discharged into the environmental system. And also technological innovation can play a big role. With better technology, it means there is going to be less pollutant discharge into the environmental systems. And also there is going to be better treatment of wastewater that allows increased water reuse and water recycling. And also lower cost can also basically lead to widespread adoption of treatment technologies and also water-saving technologies in irrigations and also in industrial production and also in household can also reduce the water consumptions in all sectors. And finally, the policy and institutional change can also play a big role on future water demand. Right now, China uses primarily a supply-based management policy. Water demand in China basically are met by increasing water storage, increasing water abstractions, and also water transfers from natural environment. The government hasn't looked at much on demand side management. So by reforming the water pricing, by encouraging water conservation and increasing water use efficiency, water reuse, and water recycling, we believe that the government can effectively reduce the water demand. And also by control water pollution can improve the water qualities. So this can also contribute to the sustainable water resource management in China. And finally, the public awareness and education can play a big role. Each individual in China can contribute and can participate in the protection and the conservation of water resources. Enhanced public awareness can help adoption of water-saving devices and also the acceptance of water reuse and recycling. And essentially, we believe that environmental education and outreach activity in all sectors can help to reduce the water demands. And right now, everybody talking about climate change. We believe that because the climate change and human activities are all related, and they all affect the water demand and also water supplies. So overall, we believe that given the limited physical supply of water in China, we believe that demand management and also pollution control are key measures for China to adopt for adaptation to climate change. Because we have no way to increase our water supply, so we have to look at how to save water, how to reduce our need, and also how to improve the quality of water, and how to better reuse and recycle this water to adapt for the climate change. And here I show the trend in water consumption in China from 1997 to 2008. This is the agricultural irrigation yield per unit area. The water consumption for irrigation per unit area hasn't changed much. While the water consumption per unit of GDP growth, or per 10,000 yuan GDP, has been decreased significantly over these 10 years. Also, the same for the industrial output. On the industrial sector, there have been significant decrease in water consumption while maintaining the same output. In terms of the municipal use or domestic water use, for the urban users and for the rural users, there has been too much change. So it's relatively constant. Well, if we plot this together, we can see that this x-axis shows the per capita GDP in China from 1949 to 2009, and also projections for 2030. Well, here this represents the total water consumption per capita. Basically, that includes the industrial water use, the agricultural water use, and the domestic use. So basically, that's the total water demand in China divided by the number of populations. And that's the agricultural water use. We can see that from 1949 to 1980, there is a significant increase in water consumption for agriculture. Then there is followed by a significant decrease. While for industrial water use and domestic water use, they have been increasing, then have been stayed relatively stable. So essentially, this is due to the fact that the total water supply in China has been stable. So basically, additional water supply or water abstraction is more difficult and a lot more expensive. And also, these are associated with greater uncertainties and can cause greater environmental damage. So there is no way we can abstract more water from the environment. So we have to look at ways how to save water. As a result, there has been significant improvement in the water use efficiency in the agricultural irrigation. So by saving a lot of water from the irrigation practice, the water was useful to support industrial output and domestic consumptions. So here is the prediction for the 2030, but I believe the prediction comes from the current water consumption. But I believe that with the right economic drivers, policy drivers, and technological drivers, we will be able to further reduce our per capita water consumptions while developing our economy. Right now, the per capita GDP in China is only around $4,000. This is around 1/10 of the United States. So compared to a lot of developed countries, we have a long, long way to go in China. And there is no way we can further increase our water consumption. We don't have the physical water available, so we have to look at ways how to reduce our water consumption and how to improve the quality of our water to make the limited water meet our needs. That's all for my talk. Thank you very much.